Hi and welcome everyone. In this video, I want to go over a couple of linear correlation problems or examples and to show you how this works. Please watch my video on linear correlation. There are examples like this that I think if I do these two problems, then you'll kind of see the details. So let's go over the first problem. It says, given the linear correlation coefficient R, make sure to watch the video so you know what the linear correlation coefficient is. I assume in these examples you already know we're going to just use them. And we're given the sample size. Determine the critical values that's from the table of R and use your findings to state whether or not the given R represent a significant linear correlation. So, and it says use 0.05. We are gonna use 0.05 all the time. If it's not given in the problem, just use 0.05. So let's go over the first one. First, we go to our table, and I wrote it here. So N is 90 and alpha is 0.05. So 90 and 0.05, we know the critical value is 0.207. So you place the negative critical value, and CB stands for critical value, and the positive one. Now, then you compare the given R in the problem. If the given R is outside of these numbers, and I wrote it for you, that means there is a linear correlation. If the given R falls inside, then there is no linear correlation. So here, if we compare it, R is 0.221, and it's right here outside range. So there is a linear or significant linear correlation. So let's double check the answer. So if you go to the critical value is, see, we found that plus or minus 0.207, so significant linear correlation. Now let's check number two. So number two, and this is the same problem. 6 pairs of data yield R equals to 0.789, and a regression equation y hat is 4x minus 2, and y bar, this is the average or the mean of the y values, is 19. What is the best predicted value of y for x equals to 5? So let's see how we can solve that. So N is 6, R is 0.789. And remember this, you use y hat, the equation of the regression, like 4x minus 2, if there is a linear correlation. So in this case, what you're going to do is substitute x by 5 and solve it. However, if there is no linear correlation, then you use the mean of y values, which is sum of y's over n. In this problem, it's already given. It's 19 if there is no linear correlation. So we proceed the same way. We're going to go to our table. N is 6 and alpha 0.05 all the time. If it's not given, just use 0.05. So let's see what we find here. 6 and 0.05, so the value is 0.811. Draw the line, just like I did in the last part, in this problem, and place the negative critical value on the left and the positive one on the right. And again, this is critical value. Then compare the given value of R in the problem. And here falls right in between these two numbers. Therefore, there is no linear correlation. If there is no linear correlation, then for this problem, the best predicted value is y bar, which is 19. If this number was here, then you use the equation of the regression line and you substitute x by that value. So it's pretty simple. Know how to use the table, and you can use the table, of course, during the exam also. Thank you for watching, and I'll see you in my next recording. Have a good one.